All right. So I want to talk a bit about why Prometheus is the way it is as an opener for the conference, or the second opener. As you might have known, as you might have experienced when you're coming from a different type of monitoring system, like Graphite or Nagios, Ganglia, StatsD, and so on, Prometheus does a lot of things very differently. And sometimes that can lead to a bit of a culture clash. Might take a while to understand why it does things differently. And sometimes you might also think, wow, that's really a stupid way to do it. Why did they do it like that? Isn't there a better way? So I just want to go into some of these decisions and show a bit our thinking behind them and why we think they're good approaches and principles. So just as a disclaimer, it's all kind of our opinionated way of looking at things. We don't have to be right in every way and maybe don't fit to every use case, but there is some thought behind everything. As a perspective, what is Prometheus really? Prometheus is a time series based monitoring system, and it tries to cover the whole breadth, like from instrumentation, getting metrics out of your processes, storing them, querying them, and then doing useful stuff with them. You know, like graphs, ad hoc debugging, and so on. And we really focused on two use cases back then, really out of necessity, which were we needed operational systems monitoring, so really a live view of what's happening in your system. And specifically, it really needed to work for dynamic cloud environments. So these were kind of the pain points we were trying to solve. So this focus means that we willfully really ignore some other use cases which we really do not intend to solve. So if you want to, for example, store logs or raw events of something, use something like Elasticsearch. If you want to trace an individual user request through a stack of microservices, use something like Zipkin. And we don't do magic-style anomaly detection, you know, that kind of fancy machine learning, data mining, statistics. We really only do explicit queries. No durable long-term storage in Prometheus itself, though there might be a decoupled way of doing that in the future. And so since we only have a local storage in every Prometheus server, there's no automatic horizontal scaling either, of course. We're kind of punting on user and authentication features, which are kind of enterprise features from our view, but I'll also go into that more later. So let's talk about the first feature of Prometheus, which is maybe one of the least controversial ones. So I just want to talk about it briefly. It's the data model, but it is different. So as you might know, like there were monitoring systems before that had a completely flat metric model, but then there were ones that had a hierarchical model like Graphite and StatsD, which you can see on the right here, where you organize your metrics in kind of a tree, and every component of the tree is one of the dimensions in an implicit way. And the label-based dimensional data model that we chose in Prometheus, you can see on the left. And there you have more like this explicit way of saying what every dimension means. And you can also access very flexibly by any dimension. So the problem with the hierarchical data model is that often, you know, let's look at a query. With the label-based data model, you just select exactly the labels that you care about, and you don't really care where in the hierarchy they live. And with the hierarchical data model, you still kind of need to know what dimensions exist and store them away. And for every job or service, the hierarchy might also have totally different meanings. So what if you wanted to do something like show me all the jobs that have a handler of /tracks or so. Then you're kind of inverting your hierarchy tree, and maybe the monitoring system isn't even indexed in such a way to be able to do that efficiently. So we think that this kind of label-based data model is really nice, and it allows for efficient cross-cutting selection. And it's also very explicit around what the different components mean. So next up, the query language. We don't have a SQL-like query language, and sometimes there are questions around that, why that is. Because SQL, you know, that's kind of standard. Data analysts know how to use SQL. And you should use SQL if you can, or some kind of dialect. But let's look at some examples of what you might want to do in Prometheus and how they would look in PromQL and SQL, in a SQL-like dialect. So one thing might be just taking the rate of a counter over the last 5 minutes. That's what it looks like in PromQL. In a SQL-like dialect that I'm making up, it could look like this. So one thing you see is Prometheus automatically selects all the labels that are output by a given expression. And in a SQL way, usually you have to select them all. I could use a star here, but then it might double select the value of which we only want the rate. So then you kind of need to know what dimensions are there. You need to select them. It's a bit longer. The metric name could become a table. Still not too bad, right? Or taking the average temperature by city in a country. That's what it looks like in PromQL. Still not too bad in a SQL-like language. But what about binary operations, which I think is one case where Prometheus really shines. Where you have one vector of time series on one side of the binary operation, whether it's a plus, minus, divided, or whatever, and another vector on the other side, and they're automatically matched on exactly identical label sets, and then propagated into the output. For calculating ratios or differences, this is very useful all the time. So I think, not sure, but I think in a SQL-like dialect, this would look kind of like this. I omitted some stuff because it would have gotten too long. Because now you kind of have to say exactly on what labels to join. You need to know what labels exactly are there, and then what to show in the output. So I think, in my opinion, that PromQL is a better choice for this kind of metrics computation that we do. And also we designed it from the beginning to be a read-only language. And we're doing writes through a more efficient input path out of band. So kind of saying select for every query would be a bit superfluous. My local monitor here turned off, but maybe I just need to press this button. Well, I don't know. I can see that one. So my next favorite topic is the pull versus push debate. So this kind of creates some worry in people sometimes. And why don't you push? I like pushing more. My firewall likes pushing more. But we think that there's a lot of benefits that you have in a pull-based world. And I first want to go a bit into the benefits. So pull really is your friend, in my opinion. When your monitoring system goes out and scrapes all the targets directly, then it already has one signal for health monitoring, for very basic health monitoring. So if it cannot scrape a given target, you automatically get a synthetic up time series with a value of 0, which you can use for upness alerting. So your monitoring system, in this case, has a signal for that already. Pull allows what we like to call horizontal monitoring. Actually, that's a term that I learned recently from Brian. Where when you have two teams and they have different services and they have totally their own stacks of monitoring and everything, and maybe one team now wants to pull some metrics from the other team. In a push-based world, the other team would have to configure all the instances to push to two monitoring systems, but only the right instances. And so it's kind of more setup worries. And in the pull world, you just say, oh, well, I'm just going to pull that service into my monitoring service as well. Of course, you maybe should still talk to the other team that's okay. But otherwise, that other infrastructure doesn't even need to know about the fact that you're there and you want something from them. So in generally, pull is more flexible. This also shows when you just run a test server on your laptop and you can scrape all production data to test new recording rules or some other kind of new monitoring setup. You can run two identically configured Prometheus servers to get high availability. At least for the kind of most recent data and for alerting, one will always be there. And one funny complaint is that when people are worrying about a pull-based monitoring system, they think, well, then it's a lot of work. I need to configure my monitoring system to know about everything that's out there. And then I said, well, you kind of probably need that anyways. Like if your monitoring system is going to tell you that something is wrong in the world, at least for most use cases, you kind of want to know what the things out there should look like and what should be there. So my argument would be you need that kind of configuration anyways. And but in the push-based world, now you need extra configuration. You need to tell the individual processes that are pushing to a monitoring system what their identity is in terms of what service they belong to and what instance they are, so you can track them down later. And they also need to know where the monitoring system lives. So it's actually in total, I would say, more configuration needed with a push-based approach. And yes, pull scales, at least for the use cases that we care about normally. I wrote a blog post about that. It's on Prometheus.io blog, I think the last post that's on there, in case you're interested in that. But I have a firewall. Or, there's people who have some network segments that are firewalled off, or there's Internet of Things people who have devices, in people's homes, and obviously you can't just pull from people's home networks, tell them to open a port on their plastic routers. So admittedly, that's not exactly the use case that Prometheus was designed for. Again, we were designed more for monitoring your data center infrastructure, but still often you can make some kind of workarounds or use some alternatives to still make these use cases work. One thing we always recommend in any case is to run your monitoring as close as possible to your targets, because then you have less possibilities of disruption in between. Kind of would be worse in all categories. It's still easy to construct, but not as easy. We don't really care so much about ease of parsing, because the parsing is usually done by the Prometheus server, although we have a little adapter that if you really want to get JSON format, that's possible. But yeah, it's less efficient. You usually have to parse the entire request body with a JSON object before you can start processing it. And I would argue that the text format is also a bit more readable, although that's obviously subjective. So in the end, we decided that JSON as yet another third protocol didn't really make sense for us to support that. We don't have clustering in Prometheus, meaning we only have a local storage that has some limited retention. We don't really do durability, but now you're thinking, well, it's this kind of clustered, dynamic, modern world. Shouldn't everything that's being built nowadays be horizontally scalable and clustered and durable? Well, clustered systems are, first of all, really, really hard to get right. They might take years until you iron out all the kinks. And then a clustered system might be the first thing that goes down when you really need it. So when you need your monitoring, maybe the network is just having some partition or it's having problems, and now your clustered monitoring system doesn't answer queries anymore. In the kind of model that Prometheus chose, you would just run multiple identical Prometheus servers. As long as you can still reach one of those, you should be fine. So we really wanted to keep the design simple. It's not just because we're lazy. And focus on this aspect of live operational monitoring. And yeah, as I said, HA is still easy to do in that way. Relabeling, our friend. So who has used relabeling in Prometheus already? Oh, okay, about half of people. Who has had the kind of WTF reaction when they first saw it? Maybe a fourth of hands or so? Okay, yeah, totally understandable. So relabeling, for the people who have not been exposed to yet, is a small domain-specific language that is part of the configuration file, where when you configure a certain service discovery mechanism to give you very raw targets with raw metadata information, to then apply a series of filter and transformation steps to them to say which targets you actually want to monitor and how. So this example, I don't know how many people can read it, but I lifted that from a Prometheus service discovery example. from a Kubernetes service discovery example. And so raw Kubernetes targets are coming in. In the first step, we're saying, OK, please only scrape instances that have a Prometheus IO scrape annotation with a value of true. And we drop all others. Then if the Kubernetes annotations have a special scheme for us to scrape the target on, we also configure a special __ scheme label and so on, which are kind of these __ internal labels are ones that will be invisible later and only used during this kind of relabeling phase. We do a similar thing for the metrics path. We do a similar thing for the port. And then we choose to map all the service labels that Kubernetes has for the instance into our time series target labels. And we do the same with the Kubernetes namespace and service name. So these options of mapping labels, transforming labels, selecting labels, targets. And so it has a bit of a steep learning curve, but it's very flexible. Now the question is, the alternative, what would that be? And the alternative, I think, would have been worse, because if you wanted to enable this for every different service discovery type that's out there, there would be a million new partially inconsistent config options that will all have to be maintained, documented, and understood. So, and then we might not even cover all the use cases that are possible with relabeling. So we thought, of course, relabeling is a bit of a mind bender at first, but it's probably the lesser evil. And we hope it's useful. Like, once you understand it, it's usually really cool. Our client libraries are a bit different than others you might be used to. If you look at examples like the statd client library, it has no state at all. When a request happens, you send out a UDP packet, like get rid of the state immediately, don't bother me with that. That's cool, like you don't need state, but then you immediately need to send everything over the network. Takes more work than you might need, actually. In Prometheus, it's a bit different. The client libraries keep a bit of state for you, but not a lot. Like, they don't actually record raw events or logs or so for you, and then you have to worry about memory growing. They just count up stuff in memory. And when Prometheus comes along, it just pulls the latest state. So you get way, way, way smaller monitoring traffic. And if you're counting hundreds of thousands of events per second, that might actually also get really, really relevant from an efficiency standpoint. And for the counters and gauges, it might not be that important, but for the two more complex history metrics types that we have, the histogram and the summary, the client libraries also do some kind of semi-complicated management and bookkeeping for you that would be really annoying to replicate yourself. And like, over all the metrics types, it also takes care of the labeling for you and remembers all the latest state of the dimensional time series. So the client libs are a bit fatter than a completely dumb protocol serializer in Prometheus, but there's a good reason for this. Everything in Prometheus is a float 64, all the sample values. Who has been bugged by that before? Anyone? Nobody here? But maybe wondered about why it is that way? One person? I mean, it's crazy, right? Why store everything as float 64s? I only need integers, and I just want to count up requests. What about precision? Do I get something like 2.00001? Can that happen? So first of all, it's just simpler. We're lazy, and simpler system is better. Can have fewer bugs, and you need to care less about type conversions and so on. So is it only that reason? Not really. If you're worried about size, it's really not the problem. The way our storage stores it, both in memory and on disk, is if something is actually an integer value, it gets compressed really, really, really well. Even if you have mixed data, floats, and ints and so on, with the new varbit encoding, you get an average size per sample and timestamp of 1.3 bytes. If you only have integers, it would be way smaller even. And the good thing is, you don't need to worry about precision with float 64s until 2 to the power of 53. That means that you can store consecutive integers in the float 64 without any loss of integer precision or funky floating point stuff happening to you until that number. And what that means in practice is to run into trouble, you would need to increment a counter 1 million times a second for 285 years. There are some fringe use cases where it could happen, but normally people should not worry about this or restart their instances every couple of years. This is really only about counters usually where you worry about this, right? So normally this is really not a problem, and it makes things much simpler. Finally, authentication or multi-user. As I said, Prometheus doesn't really support those features out of the box. First of all, there's just too many different ways of doing them, both for authentication and for multi-tenancy. And when you have authentication, then you also need some kind of SSL or TLS. And there are so many different ways of configuring TLS. And we then would have to expose them in all the different serving components. So all the exporters, the push gateway, the Prometheus server itself. So what we just usually say is, we focus on great monitoring. It would be too much maintenance overhead to try to maintain all these authentication and user management features in all the components. So you can solve auth externally in many cases by just putting a reverse proxy in front of things where you can solve it in any way you want. So you can set up authentication and TLS options in the way you want with maybe a small Nginx or similar. And with multi-tenancy, it gets a bit more difficult because now you have to thread a user ID through the entire system somehow. You can do that with some hacks. So for example, what I heard what one company does is they have a gateway in front of Prometheus where they basically add a tenant label to every time series that's coming in. And then when a user queries through this gateway also makes sure that this label is always present. So users can only see their data. Labels were not really designed for that use case, but it should work. But then again, this is like we have to scope the project to a certain scope, and we cannot support everything. But let's see what the future brings. So as a conclusion, I would say, for me, it's not specifically about Prometheus that I care about so much, but about these thoughts behind the different decisions we made and the best practices for monitoring that result from those. So if Prometheus dies tomorrow and there's some totally different monitoring system, I'd be happy as long as it still followed a lot of these decisions. And again, of course, these are our opinion. We think they're good opinions, but your miles may vary, and of course, they might not apply to every use case. But I hope it's been useful to show a bit why Prometheus is the way it is. So thanks a lot, and I'm open for questions.